Hello everyone. Today we'll see the assignment problem and how to solve it using Hungarian method. It's a typical optimization technique practically useful in a situation where a certain number of tasks are required to be assigned to a certain number of facilities on a one-to-one basis so that the resultant effectiveness is optimized. For example, assigning jobs to different workers or machines, assigning salesmen to different sales territories, assigning vehicles to routes, etc. In the next slide, we will look at a problem and then see how to solve it using Hungarian method. The problem is a production supervisor has to assign 4 jobs to 4 workers so that the aggregate time to perform all these jobs is least. Now, based on the previous timings and the experience, the number of days required for each worker to do each job is mentioned in the following table, and we have to decide which worker will do which job using the Hungarian method. Now, using the Hungarian method, the first step is consider each row one by one and subtract the smallest value from each element in that row. Now look at the first row. First row is 45, 40, 51 and 67, out of which the least value is 40. So after subtracting 40 from all the elements of the first row, what we get is this. Similarly, subtracting the lowest respective value from each row, we get the below matrix. In the second step, we have to do the same operation with the columns. Subtract the lowest value from each element of that particular column. So if you look at the first column, there is already a 0. Second and third column also have 0. So first 3 columns will remain same. But the fourth column, the lowest value is 13. And after subtracting the lowest value 13 from 17, 13, 16 and 14, we get the fourth column as 4031. That is what is the second step. Now if you carefully observe this second table, the below table, you will notice that there is at least 1 0 in each row and each column. Now let's go to the third step of the Hungarian method. In the third step, we have to draw horizontal and vertical lines that covers all the 0 elements. Now in this case, we have to draw minimum number of lines to cover all the zeros. Now here we have to consider a row or a column which has maximum zeros in it. If you look at the column B, we have 2 zeros. If you look at the row 2, we have 2 zeros. So you can consider any one of the 2 and draw a line. So we can draw a line like this. Now look at other rows and other columns and find out maximum zeros in a row or a column. Now every row or a column has got only 1 0. So we can draw either horizontal or vertical lines like this to cover all the zeros. Either you draw horizontally or vertically, you are always going to get 4 rows, which is minimum. Now the number of lines that we have drawn is 4, and the number of rows or columns or the order of the matrix is also 4. So this is the optimal solution that we have got. Now we have to do the assignment. Now using this particular optimal solution, we are going to do the assignment. First, consider a row or a column which has only 1 0 in it. So if you look at the first row, there is only 1 0, so do the assignment over there. So do the assignment, draw a square. Now the column B has got another 0 which we have to remove. We cannot do the assignment there, so we remove it. Now go to the second, third or fourth row, or the first, third and the fourth column. Every column has got only 1 0 in it. So we can directly assign over there, and after doing the assignment, we come to the conclusion that worker 1 will do job B, worker 2 will do job D, worker 3 will do job C, and worker 4 will do job A. Now if you consider the original table, we have to do the assignment, and that assignment is, we assigned this to this, we assigned this to this, we assigned job worker 3 to job C, and we assigned worker 4 job A. Now here the conclusion is worker 1 will do job B in 40 days, worker 2 will do job D in 55 days, worker 3 will do job C in 48 days, and worker 4 will do job A in 41 days. And that is what is the optimal solution. Thank you.